Hey guys, welcome back to Algebra 2. Today we're looking at problem set 44 and we're going to be solving some right triangles. We've done a little bit with right triangles with Pythagorean theorem, and we talked in the last lesson about some trig ratios with the right triangles. And just a quick refresher, we talked about SOHCAHTOA. SOHCAHTOA. And if you remember, these were, this was a little name to help you remember the relationships with sine, cosine, and tangent. And just a quick refresher, if I have sine of x, cosine of x, and tangent of x, here's our angle x. In the right triangle, remember the side opposite, that angle that we're looking at is our opposite side. The side opposite the right angle is always the hypotenuse. And the side touching our angle, not the hypotenuse, but the other side, is our adjacent. Okay, now this SOHCAHTOA was there to help you remember the ratios that we'll use. So SOHCA, or SO, is sine equals the opposite over hypotenuse. Cosine, that's this part, AH, that's adjacent over hypotenuse. And tangent, the TOA part, is opposite over adjacent. Okay, now we're going to need to use these to help solve some problems and find some missing parts of right triangles. So here's our first example. We're going to need to find three parts of this right triangle: angle B, Y, the side Y, and the side H. So you have some choices here. Whichever one looks the easiest to solve for first. What I see first is I'm going to look at this angle B. I have a right triangle. I know one of the angles is 21 degrees, so I can easily find the third angle because I know that they should all add up to 180. So if I take 90 and 21, that adds up to 111, and then I subtract that from 180. That tells me this angle B should be 69 degrees. So angle B is 69 degrees. Okay, now the next part, finding the two missing sides, we're going to need to use our trig ratios. So we're going to have some choices here, and we're going to need to pick and choose which relationship we want to use. So I can either look at angle B or I can look at the 21. It really doesn't matter. Let's focus on this 21 degree angle first. All right, now if I set up my ratios, sine of 21, cosine of 21, and tangent of 21 degrees. I'm going to look at the three ratios. The sine of 21 degrees, I look at the opposite side. The side opposite 21 is y over the hypotenuse, which is h. Now, this is going to be kind of difficult to solve because I have two unknowns in that equation. So that one's out. I move on to cosine. Cosine is the adjacent side, which is 6.4 over the hypotenuse, h. That one I might be able to solve. So I'll hold on to that idea. And then tangent of 21. Tangent is the opposite side over the adjacent side. So that's y over 6.4. Now, if I were doing the problem, my choice would be find the one where the variable is on the numerator. So I'm going to look at this tangent of 21 equals y over 6.4. Now, how would I go about solving that for y? Let me write this a little bit neater. Tangent 21 equals y over 6.4. Now, if I want to solve that equation for y, what I would do first is multiply both sides by 6.4. To do that, or the reason I do that, is to get rid of this 6.4 on the right side, which leaves me y, which is my goal, what I'm solving for. So on the left, I have 6.4 times the tangent of 21. Okay, this 6.4 tangent of 21. This is something we did in lesson 43. If you remember, to solve this 6.4 tan 21, all I need to do is type that in my calculator, just as it's written, if you're using one of the calculators I have in class. So I'm going to type 6.4, and then I hit that tangent button. When I hit tan, it's going to give me and open parentheses, and then I type 21, close parentheses, and then hit equals. When you type that in, you're going to get approximately 2.46 for y. Now, I'm going to show you this little squiggly equal sign. You're going to start seeing that in your book, and you'll see me write it. That squiggly equal sign just means approximately. Because we're rounding this off, we're not taking it out to all those decimal places. That's the symbol for approximately. So y is approximately 2.46. Okay? Now, to find h, I have a choice. I can do two things. First off, I'm going to erase a little bit of this. I can do two things. Since I now know y is about 2.46, I know two sides of the right triangle. I can find the third side with Pythagorean theorem. A squared plus b squared equals c squared. And I can plug in the parts. Or I can use one of these trig ratios. It really doesn't matter to me which way you do it. The example that I did was I used this example. If I take cosine of 21 equals 6.4 over h. Now, to solve this one for h, this time our variable is in the denominator. So I want to bring that up to the top first. So to do that, I'm going to multiply both sides by h. So I have h times the cosine of 21 equals 6.4. Now my goal is to solve for h, so my next step, I'm going to divide by cosine of 21. So h equals 6.4 cosine divided by cosine of 21. All right? To solve that, you can type that in your calculator just as it is. 6.4 divided by. If you hit that divide sign, it's going to give you a slash. And then type cosine. It gives you the open parentheses. 21. On your screen, instead of that division symbol, you should see a slash, which is a fraction sign. Okay, you type that in, and you should get h is approximately, if you round that off, you get 6.86. Now, most of these problems we will round to two decimal places. So there's my answer. Now, try using Pythagorean theorem. A squared plus b squared equals c squared. See how close you get to the same answer. It should end up almost exactly the same. All right? One more problem. This time, I'm missing two angles inside, and I know two of the sides of the right triangle. So I need to find angle A, angle B, and the side x. So where to start? I'm going to start with x first. Because I know two sides of the right triangle, I'm going to start with Pythagorean theorem. A squared plus b squared equals c squared. Most important side is c, which in this case is 7. So that's 7 squared. And my a and b, I will have x squared plus 4 squared. Now I need to solve for x. So here we go. X squared plus 16 equals 49. Next, subtract 16. So x squared equals 33. Then square root both sides. So x is equal to the square root of 33, or since on these problems we are estimating or using that approximately, we can look at the square root of 33 is about 5.74. Okay? We can use either answer to help us with some of the other steps. So x is the square root of 33, which is approximately 5.74. All right, so 5.74 for x. Now, to find either a or b, let's set up some of our trig ratios. If I look at sine of a, opposite over adjacent. So let's leave that as the square root of 33. I'm sorry, opposite over hypotenuse. Opposite side is the square root of 33. Hypotenuse is 7. Cosine of A is adjacent side, 4 over hypotenuse, 7. Tangent of A is opposite, which is the square root of 33, over adjacent, which is 4. All right, now let's do the same thing with B. Sine of angle B, opposite side from B is 4 over the hypotenuse, 7. Cosine of B is adjacent side, which was that square root of 33 over the hypotenuse, 7. Tangent of B is opposite over adjacent. So 4 over the square root of 33. Now when I look at this problem, I see those square roots of 33 floating around in there. I don't want to mess with those. So what I'm going to do, to find A, I'm going to take the ratio that doesn't have that square root, and that is cosine of A. And then same idea on B. The one that doesn't have that square root to deal with is sine of B, which is 4 over 7. Now, to solve this, this is where we did some problems the other day where we used the inverse function. We have the cosine of some angle A is equal to 4 over 7. Well, to find that angle A, I'm going to use that inverse cosine. Remember, you got to hit second and then cosine, so you get that cosine -1. When you type that in your calculator, you get the open parentheses, and then in there, we want to put 4 over 7. So you can type it using that fraction button on your calculator, or you can type in the parentheses 4 divided by 7 and close parentheses. Okay, when you do this, you should get A, your angle, is approximately 55.15. Okay, so 55.15 is approximately A. All right, when we do the same thing for B, this time I want the inverse sine. So I hit second sine, gives me inverse sine, and again, it puts the open parentheses on your calculator. You type 4 divided by 7, and it gives you angle B is approximately, go away. Sorry about that. Let me try it up here. B is approximately 34.85. Now, how do we know we did that correctly? Well, if we have a right angle is 90, A is about 55.15, B is about 34.85. You can check yourself by adding up those angles and make sure they all add up to 180. Okay? Hopefully this made a little sense. Sorry about the little menu bar popping up there. But so finding right triangles, we're going to have to use Pythagorean theorem, and we're going to have to use our trig ratios. Try to set up all the different ratios, but find the one that looks the easiest to deal with and to simplify. That's all I got today. Good luck. See me if you have questions.